Okay, YouTubers, this is Joe from ArtAlienTV, and another quick game of Interplanetary I Spy going on here. Now, I'll try not to keep this too long, but there's a lot to get through here. Now, first of all, we're going to have a look at this image, which is a recent release by NASA on the JPL site. PIA 19912. Now, this is a very good quality image. Now, one thing struck me when I first downloaded this, which maybe got me thinking and wondering about what's going on with these images, is that the TIFF image here is 72 dots per inch. Okay, now that's a much bigger file size. It's nearly 7 megabytes. Now the JPEG is 300 dots per inch, much smaller. That makes sense because it's a JPEG, contains less information. Now I've got it up here in my processor. Now, that's an enhanced clip. I'll show you that in a minute. Here is the TIFF image. Now, that's 72 dpi. Now, as far as I know, most digital cameras will take images at 72 dots per inch. And I'll show you, if I go to Shift S, it says 72 there, pixels per inch, okay? That's normal. And this is a normal, this is a so-called raw image taken by the rover, Mars cam. And if we look at the image information, 200 dots per inch, pixels per inch, I should say. Okay. Now, all the so-called raw images from the Mars cam are the same. They're all set at 200 dpi. Okay. But for some reason, this one isn't. Now, this is what may be suspicious. This is the large JPEG. Let's put that into there, and then let's have a look at the pixel ratio in there. There we go, 300 pixels per inch. So what's going on there? Have they deliberately upped the number of pixels in the image to try and maintain the detail? I think they have, because this is exactly what I do. Whenever I process any of these NASA images, what I do to clean them up, I'll very quickly show you what I do now. Shift S. Pixels per inch, 200. I'll whack a 0 in there straight away, right? And I'll go up to let's go up to 3,000. Okay, so we're going from about 1,500. So we're sort of doubling the size, basically, but we're adding a lot more pixels in there because I want to clean the image up. Okay, and if you add more pixels, it improves it. But you have to do a bilinear enlargement because that's the best quality. Okay. You don't want to pixel resize or any of that rubbish. Weighted average is okay, but that's better when you're reducing an image, okay? So that's the only ones I will ever use, bilinear or weighted average. Bilinear when you go up, weighted average when you go down, okay? So let's go back to bilinear and resize that, okay. Now, that will clean up the image already because you've added more pixels and it gives you more to work with if you're doing an enhancement of this area. And this is what look like those two, the man and woman, freeze dried in Gale Crater, and I got the video for that up here. If you want to check that out, you can see that in more detail where I've actually already renovated that image and enhanced it to show what's actually in the image. Okay, and there seems to be a little gun there and two people huddled together, freeze dried. Probably some big natural disaster or not so natural disaster as the case may be. That hit Mars, and they died and froze on the spot, turned to stone. Okay, so what we're on about here today really is the actual rover and the cameras and why they look so terrible. Now, if you look at this image again, look at the colour of it. It looks nothing like that image I just showed you here. Absolutely nothing like it. But this has been colour corrected by NASA. They've actually calibrated the colour in the image to look more like it should do. Okay, so this is real. This is actually what the sky looks like. The sky is blue on Mars. It's not red. Mars is not particularly a red planet. Some of it does look red, but there are large parts of Earth that look red as well. We didn't call this a red planet. Africa, when seen from space, looks red. Or it's kind of a brownish colour, really. But the reason why these images look so terrible is not just because of the sensor size, which is 2 megapixels, but mainly because of the filtering they use. Now, this is a bit of an argument on here. This is on Above Top Secret, where they're arguing here on this page about the camera spec. And this guy put it very cleverly and succinctly, so I thought I'd highlight this. Each of the 2 panoramic cameras has 8 filters that show different wavelengths and colours. The left camera has 1 clear filter. It shows a real grayscale version of what we would see on Mars. That's the thing I've mentioned in previous videos, that the grayscale images are the ones to go for, okay? Because they don't contain all these other crappy filters that we don't need, okay? The infrared, it has an infrared filter, a red filter, an orange filter, a green filter, blue filter, violet, blah, 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 and ultraviolet. And the right camera has an ultraviolet filter and 7 infrared filters. That's why that explains why those look even worse, because what you're getting is infrared information. So you're not really seeing a normal photograph at all. Even with the normal mass cam shots here, that is not a normal photo. There's nothing normal about that whatsoever. It has all these different filters over it. Why they had an orange filter, I really don't know. What could possibly be gained from that? A normal orange filter. Normal cameras take RGB, red, green and blue. Why are they adding orange to it? And then all this other stuff. I mean, I can understand why they might be using infrared. I can understand that. But why orange? Why bother? It just ruins them. But apparently it's because NASA can gain more information from these images with all these filters on, because they can analyze the spectral, they can do a spectral analysis of the different wavelengths and all this kind of thing, and apparently gain more information. That's certainly true with the infrared sensor and the infrared information and filters. So there we go. So I'll have a link to that below, as well as this. This goes into some detail about the Curiosity cameras. I mean, this video is kind of a follow-up to a show I done with Chris from Mars Anomalies a week or 2 ago, where we went into detail about the rover images and why they look so terrible, and about the zoom and the camera capabilities. Okay. Now I'm going to try and quickly demonstrate to you what happens with different types of digital camera photographs. Okay. So what I did, I've got various cameras here. I've got those Curiosity images, which I just showed you. Okay. I've got my Lenovo phone camera. I've got a Panasonic 24 meg camera. I've got Pentax 12 meg camera, and I've got Sony 20 meg camera. Okay. I actually have more cameras than that, but these are the ones I've used today. Now we're going to start with the lowest quality one. Okay. Now this is set to 2 megapixels. In other words, I've set the image size to approximately the same size as the rover images. Now these look pretty terrible, and I've taken some shots with all these cameras of these guys on the shelf. Now they're about 8 feet away from me, which is approximately the distance that the mass camera is from the foreground in the rover images. Okay, and look how terrible that is. That's a low res image, and it wasn't taken with a flash, and I've got a bit of camera shake there, so they're fuzzy. Now that's a minimum amount of camera shake, but because it's a dark image and there was no flash used, it's taken a longer exposure because there's not enough light in the image. Okay, so the camera's automatically taken a longer exposure, which means you've got a shaky image and it looks pretty terrible. Now had I taken this with a tripod, it would have been a lot sharper because there would have been no camera shake. Okay. Now I wonder whether some of these images that we're getting from the rover are suffering from a little bit of camera shake, because if they're using a high level of zoom, which they do, and I did on this image, okay, this was at maximum zoom. Now this is on a crappy, it's a 13 meg camera, but I've set it to 2 meg, but it's got no actual telephoto lens on it. Okay, which means I can only digitally zoom in to the image. Now this is 7 or 8 feet away, and that proves that, you know, it's not all about the size of the image, it's about the actual level of zoom and the light conditions. Okay, so bear that in mind. It looks shaky because it is shaky, and it looks blurred because it's shaking, but not very much shake, but enough to ruin the image. Now this is taken from closer up, same settings, no flash, only about 2 feet away from me, right next to me on the sofa where I'm sitting now. And even these images aren't very good. I had to take 3 to get a clear shot because I got camera shake, okay? Now look at that dial there. Bad image, another bad image, but the third one isn't too bad. And you won't get any better than that really unless you use a tripod. If I was to use a tripod, that would be sharper. You would get a sharper image. But the beauty with a digital camera is you just keep on taking shots, and one of them is bound to be more in focus than the others. That's the beauty of it. And this is the whole point of the digital camera. Okay, so that's a demonstration of sharpness with a low res image. This is 2 megapixels. And poor lighting conditions. Now had I taken that outside, that would have been much better. These would have been much clearer and sharper because there would have been a lot more light. Now, I'm going to show you the same camera set to 13 megapixels with a flash on, and it still looks pretty terrible. Why does it look terrible? It does look better, but it's still not very sharp, it's still fuzzy. You've still got this kind of halo around this stuff where it's not properly focused. It's because I haven't got a telephoto lens on the camera, okay? It doesn't have that capability, it doesn't have the telescopic lens that I can zoom in and get a sharper image with, okay? Because this basically is a telephone camera. It's not a proper camera. It's not a real camera at all, really. Now, this is the same camera, no flash, set to 13 meg, full spec on this camera, taken outside. What a difference. You have very good light, which means it's taken a short exposure, and you have a sharp image. Now, this is taken with no zoom at all, because the camera doesn't really have any zoom. So the images come out really good because I actually just walked up to the sculpture thing here, just walked straight up to it and took the camera right up to it and took a full view shot without using any zoom. So that proves that the zoom can actually ruin a photograph. Now here's another shot. This was taken on holiday in Malaga of some graffiti in the town. Really cool bit of artwork here. Now this was taken obviously from the ground. This is a couple of stories up, but this is very large, so it looks good. And I probably zoomed in a little bit on here, a little bit of digital zoom, just to get it in a bit closer. But it's good, and it's a high quality image. And there's a lot of pixels in this image, so you can afford to zoom a little bit, as long as the light conditions are good and it takes a short exposure. Okay, right, so that's enough about that. I could go through all these cameras, but I'll just I'll show you the best version here. I'll quickly show you. Now this is a 20 meg camera, and I'll show you ones without a flash. Okay, not bad. That's set to 1 meg. This is a 1 meg shot. Okay, I lowered the rating on the camera, so it takes a 1 meg shot. Not a bad image. But this is a very good camera. It has a very good zoom on it, a very good lens. But this is basically on its lowest setting. So if it takes them that good on its lowest setting, that goes to show how far cameras have come since 2004, when the Curiosity Rover camera was designed and built. Okay, that's a 1 meg shot. If you look at the size of the image, 1.155 kilobytes. That's really small. Okay, now this is a full size shot, over 6 meg of the same thing. That's at full spec, but with no flash, I don't think. Okay, so there we go. That's how sharp it should look with a good high-res camera. That's the same shot. And here's one with a flash, but it's cropped. Now, let's see what size that is. Yeah, now this is set to 2 meg, which is approximately the same size as the mass cam. That's taken with a flash, as if it was outdoors, so it's lighter, and you've got a pretty good image, nice and clear. It's a bit too bright, if anything, but you can read the lettering up here. It's not bad at all. So that is actually a low, what I would call a low res image, but it's good quality. So you can get good quality images with a low res camera. Okay, it's not all about the size of the sensor. Now let's go to the Panasonic. This is the best one. This is a 24 meg camera. This is a full res shot here with the flash on, I think. And that goes to show what can be done with a high res camera. But this is still 72 dpi, dots per inch. This is just a much, much larger image. The way digital cameras work is they take not particularly sharp images, as in dots per inch. They just take them much larger. So when you view them on the page, they just look better because it naturally compresses the image and tightens up the edges. Okay, if you understand what I mean. Now I try not to be too technical here because unless you're a printer, you probably won't understand all the stuff I'm saying here, or unless you're into photography or printing or something. But this is also another full res shot on the Panasonic 24 meg. Now this is actually a video camera which takes stills, and it's got like extremely powerful zoom on it. It's got a 50 times zoom, really impressive zoom on this thing. And you can, this thing is only about what, 7 or 8 millimeters long. This thing, it's very small, and I've got it zoomed right in. I was about 10 feet away, zoomed in, and look at the detail you can get here. Now, you can get something like this level of detail on some of the other cameras on the Rover, like the Ken Cam, or the Mali Cam, or the other cams, depending on how they're used. Let's go to the Rover page. You've got all these different cameras, and some of them are designed purely for taking close-ups, like macro photography of the ground. And you can see individual grains of sand and very good detail. So even though it's only a 2 meg sensor on the Rover, it's still capable of good quality images as long as they can move the camera close to the subject. Okay? Because even though some of these cameras have got massive zoom telephoto lenses on them, some of them haven't. They have to physically actually get the camera a bit closer. Okay? I'm starting to digress now, so I think that pretty much covers it. So basically what I'm trying to get across here is that the quality of the images is not down to the size of the sensor. It's to do with these filters. It's to do with the orange and infrared filters that makes the images look terrible. But all you have to do is color correct them. And let me show you very quickly how I do that. I have showed in some of my previous videos how I do that. Let's try and get this to look a bit more like that one there in the sort of the color range. Let's go to adjust, automatic color balance, and let's go to about sunlight. Go there. Now that's more of an approximation of some of the colors you're seeing here. Okay, so that's a very quick thing you can do. That all I did there is add a daylight filter to it. Let's go here, automatic color balance. I won't actually do it again. But this basically is a temperature filter, and you can either make it much bluer, like this, or much warmer, like that, which we do not want because they've already done that to the image. So by making it more like sunlight, let's go a bit further over. Yeah, well, I've already done it, so it makes it bluer, and that's probably nearer to the actual color, and it's starting to look like some of these browns up here. Okay, so that's an approximation of what they're doing to the image anyway. That's the way I do it. There's probably more complex and more accurate ways of doing it, but it works for me. So that's really what you have to do to the images to clear them up, as well as add contrast and enlarge them. I always enlarge them and try and sharpen them up a bit. That's what you got to do. You had to use a color filter to try and correct them, and this is a very good example of that. I mean, this TIFF is a really good quality image, 72 dpi, which is the original resolution of the camera, I think. And this is what looks like that ship-like structure there, which I've probably showed you already in previous videos. But I've been doing a bit more work on it because this is a good quality image to work from, better than I've had before of this area. So I thought I'd redo this to get some more detail out of it. And you can see there's some very straight and rectangular pieces to this, and it looks interesting. But there's still a limit of what you can get out of this image, because basically this photograph, even though it's zoomed in, it was taken from about 2 miles away, about 3 kilometers, probably a bit less than 2 miles. And it's not focused particularly on anything. It's probably set to infinity. Now that means that everything is very slightly out of focus. It's not particularly focused on one thing, because if it was focused here, then everything else would be blurred. It's just taken an infinity shot so that everything is slightly in and slightly out of focus. Okay, so I hope that explains some of the details about these images, and really you really have to color correct them, like I showed you. And if you've got Photoshop, you can just do a white balance, and you can set that to look more like a natural daylight shot. But Mars does have a blue sky, and what does that mean? Blue sky probably means oxygen. There's probably a lot more oxygen up there than we were being told. If there wasn't, then why would it be refracting or showing the blue colour? Because we know that oxygen reflects blue. Okay, this is why water is blue, because it contains high levels of oxygen. So there we go. So thanks for watching, everybody. The links will be below to all these things. I'll see you soon.